So I wanted to talk through this bit today. Instead of actually doing the demo, I think it's enough to just talk about it sort of in a theoretical way, because it's quite easy to just follow some instructions from the website about this or some course. It's very clear, and it's just like copying some code and then doing the implementation, and it all kind of works quite well. I found that it works well if you just do the stuff on that tells you or gives you instructions on how to do it on the platform, AWS platform, as opposed to doing the stuff locally, because locally you have a lot of different problems, like different operating systems. You might be using Ubuntu or Windows 10 or something like this, and or Mac, and you'll have those differences on your local systems. Then you have to see how it goes to files, how it sort of references file systems. So that's a little bit of a difference. So, but when you're generally just using the stuff that's all in AWS on the cloud, then it's just going to work more easily, because there isn't so much difference in the environment. So the thing that I'm talking about is PySpark and glue crawlers. That's what we're going to talk about here today. So glue crawler. Glue crawler. So that's what we're going to talk about here. And this is basically something where you can put in some PySpark. So PySpark is a sort of interface, just a API really in Python for Spark. So this actually allows you to sort of go in to S3, so your bucket's in S3, and you'll have here some things like CSVs and these flat files. So you can use this to interrogate your CSVs, and you can see the metadata, which is the columns and the data types that you might be, and create some data types from that metadata, from those columns, and then you can just expose it out into Athena here. And so here you can show it as a sort of so it looks like a database really. You're allowed to do SQL on it here. So that's one of the good things about Athena. So you can just write SQL, and then it's not actually going to a database, it's actually just looking at metadata that you've sort of exposed here, and then it's actually the data that is in CSV files. So you're querying CSV files basically. So that's what the power of this thing here is. So let me just show it like that. So then here what we have is, so if we draw a line under this stuff here, and then a similar vein really, where you can still use this. So another use of this that is very easily demonstratable is glue crawlers again. A glue crawler again. Glue crawler. Then the same thing I wanted to show you here. This is also using in PySpark, the same kind of thing, and also S3 as well, and then also CSV. So you have that in a bucket, but then what you can do is you can pull that first over to here, and then also once you've pulled it over here, you can also sort of push it back over here into something called a Parquet file. So Parquet is kind of a very structured file system little folder, and you can have different partitions, partition by column. So because it's very structured, highly structured data, you can sort of put it into these columns, and then you can sort of these partitions of columns, and then you can sort of query it by that data. So for example, you can split up your rows or your dates, your rows by, you can split up your data that you might have a date column, and then you might split that out into years and then months, and then you might split that out into, you might have that as another column, and then that will be like a partition that you have in your data. So what you can do with that then is you can also do the same things here with Athena, and because it's a database kind of thing, you can do the SQL stuff. But this time here, because you're doing this with a Parquet file, going through the crawler and then going into the SQL, you can do the query, and it's sort of column based, and because it's column based, you can sort of query out maybe just these columns, just the first two columns, and then the query that comes back only takes back maybe 50 KB, something like this. Whereas if you had a CSV here and you were doing even just if you were querying this, you will still be having to bring back the whole of the data first, to scan the whole of the data before you can actually just take those two columns. So every time you did a query, it would still be 100 KB, even though you're pulling these two same columns here. That is why, because it's a CSV, then you're doing this, you have to bring out the whole of your 100 KB here. But if you're doing a partitioned Parquet column store data, then you're just bringing out what you need, because it's partitioned by the column and it's queried by the column, so it will just be smaller and more efficient. So that's the idea, and that's the sort of end of this talk. So I hope it's been useful. Thank you very much for watching.